Good afternoon, ladies and gentlemen. Welcome to Japan Seminar Challenges by Japan. Thank you very much for your attendance. I am Ikuo Hamanaka, working for Japan Ship Center, Jetro London. It's my honor to serve as a moderator to this event. I hope you are enjoying this wonderful maritime exhibition, Posidonia here, in the brightest weather. Today, we like to share the latest activity from Japanese maritime industry in this seminar. This seminar is organized by Japan Ship Exporters Association and sponsored by Nippon Foundation. In this seminar, we will cover the most interesting and challenging topic in the maritime industry, which is greenhouse gas emission reduction as well as energy efficiency. I believe all of you will find them interesting, and I'm sure you will be satisfied with our event. Therefore, I hope you can attend the whole of this seminar. Well, starting this seminar, we'd like to have an opening remarks from Mr. Shunichi Miyanaga, President of Japan Ship Exporters Association. Please welcome Mr. Miyanaga. Floor is yours.
Good afternoon, everybody. I'm Shunichi Miyanaga, President of the Japan Ship Exporters Association. At first, I'd like to express my sincere gratitude for all of you participated in this Japan seminar, and would like to make some brief remarks of this occasion. On this occasion. As you all know, the current world has become quite complicated and uncertain. Indeed, we face problems such as securities of energy, critical minerals, and restructuring of supply chains caused by fragmentation. We also face new technological issues such as artificial intelligence, which is expected to accompany not only tremendous benefits, but also increase in demand for the future electricity and even concerns about its malusages. As we need to continue lowering the greenhouse gas emission from existing facilities that uses fossil fuels and our global businesses are going to pursue the multiple pathways toward net zero emission society. And under close collaboration with the international shipping industries, Japanese shipbuilding industries is also tracking measures for decarbonization, applying technologies such as high fuel efficiency eco ships, as well as alternative fuel-powered ships using fuels such as ammonium and hydrogen, together with the development of carbon dioxide carriers, storage on board, and electric motor-powered ships. Today, 8 private companies and 1 public organization in Japan are here for presenting the current activities of the Japanese shipbuilding industry under the title of Challenges by Japan. Nihon Shipyard Company Limited, Kawasaki Heavy Industries Limited, Mitsubishi Shipbuilding Company Limited, Yanmar Power Technology Company Limited, Daihatsu Diesel Manufacturing Company Limited, Mitsubishi Heavy Industries Marine Machinery and Equipment Company Limited, Chuguk Marine Paints Limited, Mitsui OSK Lines Limited, and Nippon Kaiji Kyokai, NKK. Moreover, Mr. Stelios Korkordilos, who is representing the Union of Greek Ship Owners, will deliver the keynote speech, Challenges of Maritime Decarbonization. We'd like to appreciate and look forward to hearing. All these companies are introducing the excellent and advanced technologies, and we want to share each other common problems in the areas of both marine transportation and the shipbuilding industry. By the way, this summer will be streamed of this seminar. Yes, will be also streamed live on YouTube through our own digital platform. In addition, the seminar can be seen as public viewing through a large display in the Japan Pavilion. A mini seminar will also be held by the present organization in the tomorrow afternoon using the large display in the Japan Pavilion. You can confirm the details of seminars program on JSEA digital platform. And you could also see the virtual pavilion in which 4 booths of Japanese companies, in addition to real 9 shipbuilders participating. You can access JSEA digital platform with the QR code printed on the program provided. Please enjoy JSEA digital platform. Finally, I'd like to conclude by sincerely wishing you all a meaningful and engaging seminar and look forward to a successful Posidonia 2024. Thank you very much for your attention. Thank you.
Thank you, Mr. Miyanaga. In this special year of anniversary of 125 years of long-standing diplomatic ties between Greece and Japan, we are really delighted to have a distinguished guest from the Union of Greek Shipowners today. Mr. Stelios Korkodilos, Technical Advisor of UGS, will give us a keynote speech titled Challenges of Maritime Decarbonization. Please welcome Mr. Korkodilos. The floor is yours.
Good afternoon. It's my pleasure to speak to you today, and I would like to thank the Japan Ship Exporters Association for their kind invitation. The theme of today's seminar, Challenges by Japan, is very timely, as the industry does indeed face many challenges, from geopolitical changes and trade barriers to continuing piracy and attacks on shipping by Houthi rebels, putting our ships and crews in danger. A key challenge the whole industry does face is how to decarbonize shipping without causing disruption to our industry and undermining its vital role in supporting global trade and bringing energy and food security to the whole world. To borrow a phrase from the Secretary General of the IMO, no shipping means no shopping. It's really that simple. International shipping is by far the most energy efficient form of transportation. And despite transporting over 90% of global trade, it accounts for only around about 2% of global greenhouse gas emissions. In fact, the energy efficiency of shipping has been improving. As per figures from Clarkson's, despite transport demand almost doubling over the last 20 or so years, greenhouse gas emissions from shipping have fallen from around 3% in 2000 to about 2.2% in 2022, having peaked in 2008. Data from the IMO shows that the global fleet's carbon intensity has also improved by around 30% since 2008. This has again largely been driven by improvements in energy efficiency. Shipping is an energy-intensive industry. Unlike other industries, ships need extended autonomy. They carry their own fuel, and deep-sea voyages are measured in weeks, not hours or days, which is the norm in other industries. This makes decarbonizing shipping a major challenge. We welcome the 2023 IMO greenhouse gas strategy, and we applaud the fact that shipping, whilst recognized as a hard-to-abate sector, is now leading in this challenge, with a target to reach net zero by or near 2050. However, we also recognize that the targets, and especially the 2030 checkpoint, are very ambitious and very close. We, as an industry, are doing our utmost to ensure that we meet these targets. However, we cannot achieve this alone. Shipping is dependent on out-of-sector stakeholders, including charterers, ports, and banks, amongst others. In particular, the industry is reliant on fuel producers and suppliers to ensure that sufficient quantities of suitable and safe fuels are available in all ports around the world. This is a massive task, with estimates of the cost to decarbonize shipping running into the trillions of dollars, most of this for investments ashore. We are therefore, to a large extent, in the hands of others. New fuels and technologies will also impact on our crews, a vital part of our industry which is not often given the importance they deserve. These fuels need to be safe, and the crew needs to have the training to be able to operate these new ships of the futures. Now, whilst these new next-generation green fuels may be a solution for new buildings, we must also not forget the many thousands of ships that are already on the water, representing an investment of billions of dollars, and which will need to be able to trade into the future. For these ships, we will need drop-in fuels, likely to be biofuels. However, we will be in competition with road and particularly aviation for access to these fuels and the feedstocks required to produce them. Shipping is at a disadvantage to these industries in access to these fuels. Policies such as road transport biofuel blending mandates have resulted in uptake of fuels in the road sector. Aviation, whilst having similar constraints to shipping in that it needs an energy-dense fuel and has limited choice in the near term, should be able to pass on the cost much easier to their passengers, making them able to pay higher costs. Now, given the limited availability of such fuels in the short and medium term, we will need to find other ways to further improve the greenhouse gas efficiency of the existing fleet. This will likely require retrofits and upgrades to our vessels. However, given the number of vessels and the short time scales, we will be constrained, both by manufacturers' ability to provide the equipment, but also by the skilled personnel and yard capacity to install these new systems, be they air lubrication, wind power, or anything else for that matter. Finally, we need to consider the regulatory aspects. During the next year, the IMO will agree new mid-term measures to support the greenhouse gas strategy. It is imperative that these measures recognize that shipping is not homogeneous. It includes a wide range of vessels, trades, and owners, each with their own characteristics and requirements. The regulations need to recognize the complex nature of our industry. They need to be suitable for all vessels, all trades, and maintain a level playing field. In short, the regulations should support and not undermine our industry. We also need to avoid a multitude of local regulations such as the EU ETS. Shipping is a global industry. It needs a global regulator, the IMO, with a robust but practical set of regulations designed to ensure a level playing field for all of us. It's clear that decarbonizing shipping is going to be a major challenge and will keep us all very busy in the coming years. That's why I'm particularly happy to be here today to listen to what our friends and partners from Japan are developing to help the industry in this transition. Greece and Japan are both major shipping countries, and we have a long history of cooperation. Japanese ships and technologies are rightly considered to be amongst the best in the world. Greek ship owners have a long tradition of ordering ships at Japanese yards and using Japanese equipment on their ships. This will continue into the future. So again, I would like to thank the Japan Ship Exporters Association for their kind invitation, but also all the companies that are presenting here today for taking the time to present their technologies and showcase their solutions. It's my honor to be here today, and I very much look forward to the presentations from our Japanese friends and partners. Thank you all very much.
Thank you, Mr. Kolkodios, for his very insightful baseline, making baseline for this today's presentations. Thank you very much. Now, I'd like to move to the presentations. This seminar is divided into two parts with a 10-minute break in between around 3 p.m. There will be 9 presentations from Japanese industries. Time for questionnaire will be allocated after each presentation. Your questions and comments will be very much appreciated. Please do not hesitate to take the floor. For your information, this seminar is scheduled to finish at 4:15 p.m. We need to be a bit efficient to run through the program on time. Please note that break may be shortened depending on the progress. We would appreciate your cooperation in this regard. So, let's start with the first presentation. The first presenter is Mr. Yuki Izumi from Nihon Shipyard. He will give you their current initiative towards Net Zero Society. Please welcome Mr. Izumi. Floor is yours.
Thank you very much, Hamanaka-san. Hello, everyone. My name is Yuki Izumi from Nippon Shipyard, UK. And today, I introduce our approach to Net Zero Society. And firstly, before we get to the main topic, let me introduce my company, Nihon Shipyard, NSY. Imabari Shipbuilding and Japan Marine United have established joint venture company as Nihon Shipyard, NSY, on 1st January 2021. And Imabari is the largest shipbuilding company in Japan, and JMU is the second one. And this is our workflow. NSY is responsible for upstream work for all merchant vessels to be built at both Imabari and JMU. And our market share for new building is 50% in Japan and 8% in the world. And we have 14 shipyards in Japan, and we also have overseas offices in Athens and London. Actually, I'm based in London office, not Athens, but welcome you anytime. And up to now, we have lots construction records of various types of vessels. And recently, our main products are bulkers and tankers and containers. And that's our company, Nihon Shipyard, NSY. And now let's proceed to the main topic. As you know, new IMO GHG strategy was set in MEPC 80, and MEPC 81 in March this year, held in March this year. Several proposed measures for GHG reduction were on the table, but there was no agreement yet. So next MEPC in October this year is the key. And new rules are scheduled to be entered into force in 2027. Anyway, our final goal is to reach net zero emission by 2050. So what can we do for GHG reduction? There are several approaches to GHG reduction. First key is resistance reduction. We will continue improvement of hull forms and energy-saving devices because it's very important to improve the vessel's fundamental performance. Also, alternative fuels are important approach And we have other ways, such as renewable energy, operational solutions, and other technologies, such as shaft generator and carbon capture systems. And the key point is to combine these various technologies. And from next slide, I'd like to explain our approaches to GHG reduction. Oh, sorry. First one is file form improvement and energy saving devices. Our biggest sales point is that we have some test tanks in our technical research centers. And so we can develop high efficient, high performance hull forms and optimize our energy saving devices. And also we think vessel's performance under actual sea condition is very important. So we've developed a unique bow shape and round shape accommodation house to reduce resistance from waves and wind. And with this technical background, we've developed a new bulk carrier that achieves 40% EEDI reduction using conventional fuel. And as I mentioned, the IMO's measures will continue to be discussed in MEPC. However, the EU regulation known as Fuel EU Maritime have already been established and scheduled to begin in January next year. And the Fuel EU Maritime is the provisions setting a limit of GHG intensity of fuels used on ships. And so even if fuel consumption is improved, GHG intensity of fuel is not reduced as long as using conventional fuel. This means that switching to alternative fuels is necessary. Technically, GHG intensity can be assessed across a fleet of vessels. So the fuels used by vessels in fleet need to be gradually transitioned to low emission fuels or zero emission fuels to meet annual emissions limits. And we carried out a fleet study in case of a fleet of 10 vessels of our Newcastle Max. The study result is 4 vessels need to be low emission fuel like LNG by 2030, and all vessels need to be low emission fuel by 2035, and 8 vessels need to be zero emission fuel like ammonia by 2050. So we as shipyard must build alternative fueled vessel for our customers. And this slide shows our activities for alternative fueled vessels. And for LNG fueled vessel, we've delivered car carriers and Newcastle Max. And we've developed Dunkirk Max and VLCC. And for methanol fueled vessels, we are developing a bulk carrier, and we have already received some orders for container carriers. And for ammonia fueled vessels, we have 2 ongoing projects. One is ammonia fueled ammonia LPG carrier, and the other is ammonia fueled Newcastle Max bulk carrier. And through these projects, we will establish our technologies. And renewable energy is also one of the solutions. And we can conduct the installation study for a wind-assisted propulsion system called WAPS. And energy saving from WAPS does not depend on the fuel type. And when WAPS is installed on alternative fueled vessel, payback period is shorter and benefits are greater compared to the case of conventional fueled vessel. And regarding other technologies, carbon capture system, shaft generator, air lubrication system are also major one. And we've carried out feasibility study, and we can conduct the installation study for such technologies on our vessels. And in closing, this is today's summary. There are several approaches to GHG reduction, and resistance reduction is very important for fundamental performance for vessels. Switching to alternative fuels is necessary for reducing GHG intensity, and it is possible to combine multiple technologies. And here is what can we do. We can develop high-performance hull forms and optimize our energy-saving devices. And we can build alternative fueled vessels, and we can conduct installation study for WAPs and other technologies such as carbon capture system, shaft generator, and air lubrication system. And we can provide solutions for net zero society. And finally, let me close today's presentation with our company's motto, growing together with our customers by the shipbuilding and offshore technologies. Thank you very much.
Thank you, Mr. Izumi. Now I'd like to open the floor for the questions. Raise your hand so staff can bring a microphone to you. Please give us a name and the company in the beginning of your interventions. Is there any questions from the floor? Lady on the left.
Hi, thank you so much for your presentation. My name is Helen Tong, and I'm a lawyer entrepreneur, and I work with startups. And I'm very interested in your presentation on FUE EU, and I appreciate you mentioned you're doing R&D. What are your perspectives in terms of compliance with FUE EU for Japanese, I guess, ship owners and charterers potentially in entering the EU? What are your thoughts on that? Yeah, thank you.
I'm sorry, I didn't catch it. sorry.
So for example, come August the 1st, there are reporting requirements, and then January 2025 is where the regulation actually kicks in. So I'm very interested in knowing what preparation, I guess, the Japanese shipbuilding company or are potentially doing. Yeah, thank you.
Thank you for asking me. And FUE EU Maritime is the regulation of GHG intensity. So we have to, ship owner have to change the fuel or pay a penalty. So they calculate which is better. But now the fuel supply side is there's some challenge for the fuel supply side, and Japanese ship owner have a trumper vessel, so it's difficult to get a fuel while during voyage. So it's tough. It's challenging situation, I think. Yeah.
Thank you. I see other hands there. Sorry.
From Wednesday, I was interested to the webs. Actually, I have seen on the this March on the wind propulsion system. So that one, is that because I know at that time in New York it was presented by Missouri, so this system have only been installed on their own, like the MOL vessels. Is any of your other clients like have request to install those
yeah.
wind propulsion.
Thank you for asking. Actually, we have no experience to install our new building vessel, but if ship owner request, if we receive some request from ship owner, we can study the installation work. Yeah.
Thank you.
Thank you for the question. And next question will be on.
Yes.
Yeah.
My name is Mulham Al-Drubi. I am from Dealgo Corporation. It's a company based in Canada. My question that actually attracted my attention about 2050. Am I understanding that the industry will be having totally vessels that will run on batteries, for example, like the car, Tesla, etc.? And what would be the artificial intelligence role in that? How the artificial intelligence is going to improve the industry and minimize the consumptions of the fuel in this particular industry?
Thank you for your questions. We have any approaches to GHG reduction, and I think AI is it is possible to use AI technology to operational solutions like voyage optimization and for example, I have one idea, and when in case of the ship which is equipped the wind assisted systems, they if some AI system is installed, they can choose the route which is suitable for WAPs. Yeah. Do you understand what I mean? So sorry.
Thank you. And we are running out of time, so this next one will be the last question from the floor. Maybe you, gentleman there.
My name is Yang from Korea Exim Bank. You showed me the result of Harform improvement, and you said the amazing result that the 40% of fuel efficiency you got, and I think it's an amazing result. And I think Korean engineers say that the maximum 15% maybe could get by the Harform development. How could you get the amazing result? I wonder.
Yeah. I explained, as I explained, we have test tanks, and NSY, since NSY is established, we can gather technologies from Imabari and JMU. So we can use both technologies. Since NSY is established, we can develop more efficiency hull forms. Yeah, and yeah.
Thank you very much for all of your questions. Now, I'd like to move to the next presentation. Please give big hands to Mr. Izumi.
Thank you very much.
Thank you, Mr. Izumi. Then, next presenter is Mr. Eiji Tamoto from Kawasaki Heavy Industries. He will give you a current development of the hydrogen fuel propulsion systems for ships. Please welcome Mr. Tamoto. Floor is yours.
Thank you for Hamanaka-san. Sorry, please waiting. Okay, let's start. Hi, good afternoon, everyone. I'm Eiji Tamoto of Kawasaki Heavy Industries. I will talk about the development of the hydrogen fuel propulsion systems to achieve zero-emission ships. Today, I will talk about three things. First, demonstration of large-sized L2 carriers. Second, propulsion plant of liquefied hydrogen carriers. Third, future outlook of propulsion systems. Kawasaki aims to realize a hydrogen society toward carbon neutrality. The key factors to achieve it are maintaining a stable supply of hydrogen and securing affordability. There are several places around the world where the hydrogen can be produced by excess electric power. There are various sources of electrical power, for example, fossil fuel and renewable energy. The produced hydrogen is liquefied, stored, and transported in large quantities in a long distance, similar to the transportation of LNG. This is concept of CO2-free hydrogen supply chain. The objective is to establish a stable supply of hydrogen while suppressing CO2 emissions. CO2 hydrogen can be produced by using renewable energy. It can also be produced from fossil fuel when combined with CO2 capture and storage systems. The produced hydrogen is liquefied and transported to Japan by liquefied hydrogen carriers. In Japan, the hydrogen is used for power plant and other consumers. For the transportation in the long distance, mass transportation of hydrogen is needed, and large-size L2 carriers are also necessary. Kawasaki has built more than 40 LNG carriers and more than 60 LPG carriers. Therefore, we have a lot of experience and technical knowledge about propulsion plants for liquefied gas carrier. In 2020, we built Suiso Frontier, world's first L2 carrier, which proved that it was possible to carry LH2 in a long distance. Now, we are developing large-sized L2 carrier by using our many experience of liquefied gas carrier. The large-sized L2 carrier that we are developing. The most important feature in this ship is that it can achieve zero emission by using hydrogen gas as fuel. So when we use hydrogen as fuel, we have to understand its characteristics. There are mainly 4 important points to design the hydrogen propulsion plant. So first, low gas density and diffusion. Hydrogen gas has a low gas density and diffusion rate is fast. So it's important to be well ventilated in enclosed space and purge the gas with inert gas. Next, flammable. Hydrogen gas is easy to ignite and it catches fire even if static electricity. So it's necessary to have anti-static measures and to avoid flammable objects. Finally, embrittlement. Hydrogen gas makes metals brittle, so it's important to select suitable materials for it. We must consider the characteristics of hydrogen gas to keep hydrogen safety. There are three principles. First, no leakage. Second, no accumulation. Third, no ignition source. We are carry out the various analysis and risk assessments to eliminate the risks of hydrogen fire. Kawasaki is developing the propulsion plant with hydrogen safety in mind. Void of gas handling from cargo tanks is very important on LH2 carrier. There are three requirements for its propulsion plant. First, propulsion plant can use void of gas for propulsion plant. Second, propulsion plant can control the pressure and temperature in cargo tank. Third, propulsion plant shall have high safety and reliability. To satisfy these requirements, we selected steam turbine plant for large-sized LH2 carrier. The overview of the propulsion plant of the large-sized LH2 carrier. Void of gas is generated in cargo tank due to external heat. It is compressed by fuel gas compressor and heated by fuel gas heater, and supplied to main boiler like a yellow line. So, and the hydrogen dual fuel boiler burns the hydrogen gas and generates steam and supplies to steam to main turbine. So, this process can achieve zero emission because no fuel oil is used. The hydrogen dual fuel boiler. This boiler has three fuel modes: fuel gas mode and fuel oil mode and dual fuel mode. It can burn only hydrogen gas without fuel oil. Burner was developed based on LNG fuel burner, and prototype burner was tested in April 2021. We have obtained approval in principles from Class NK in 2022. The hydrogen dual fuel engine the Kawasaki are developing. Capacity of this engine is about 2.4 megawatt, and it has exhaust gas recirculation system for gas mode operation. It can be operated with hydrogen fuel at a calorie-based ratio of 95%. Kawasaki has obtained approval in principle from Class NK. From this year, we will carry out combustion performance test with a prototype engine. Commercialization of this engine will be scheduled in around 2031. There are mainly four types of hydrogen propulsion systems. First, steam turbine plant. It consists of main boiler and main turbine. It's going to be used for large-size H2 carrier, which can achieve zero emission. Second, diesel electric plant. It consists of generator engine and propulsion motors. The generator engines can burn hydrogen gas. Generally, diesel electric plant is expected to have higher fuel efficiency than steam turbine plant, but the dual fuel generator engine are still under development. Third, slow-speed diesel. It is directly coupled to the propeller. This has also expected to higher fuel efficiency, but this is also under development. Finally, electric propulsion plant by using fuel cells and batteries. This can achieve zero emission. Power output of this system is smaller than others from now. So it's suitable for small-sized ship. We will need to monitor the trend of development of each propulsion system in the future. We gained available experience and know-how by building Suiso Frontier and planning the large-size H2 carrier. Going forward, Kawasaki will continue to develop the H2 carriers in a variety of size according to the market needs. And we will develop propulsion plants suitable for each liquefied hydrogen carriers. That's all for my explanation. Sorry, and this is our booth information. Please come to our booth 4.202 in Hall 4. Thank you for your attention.
Thank you, Mr. Tanaka. Now I'd like to open the floor for questions. Please raise your hand for the microphone. Is there any questions from floor? No? Okay. Thank you very much for your presentation.
Thank you.
Yeah. So let's move to the third presentation. Next presenter is Mr. Kohei Saigo from Mitsubishi Shipbuilding. He will give you the current activity towards the realization of ammonia as a marine fuel to achieve carbon neutrality of maritime transportation. Please welcome Mr. Saigo. Floor is yours.
Thank you for your introduction. So today I will talk about ammonia as marine fuel. So first of all, I'm Kohei Saigo from Mitsubishi Shipbuilding. I'm a naval architect for 10 years, and I'm mainly in charge of the design of LPG and ammonia carrier. So I was also seconded to Maersk Mckinney Model Center in Copenhagen last year, and I researched and studied the decarbonization of the industry. And this is the picture of Nagasaki City in Japan, where we work. This is surrounded by mountain and a beautiful ocean, as in the Athens. It's a very beautiful city. And let me introduce about us, Mitsubishi Shipbuilding. We were established in 1884, and now we are one of the group companies of Mitsubishi Heavy Industries. And we are doing new building, repairing, and engineering of merchant vessels, and also supplying the environmental technology, such as SOx scrubber, fuel gas supply system of LNG and ammonia, and CO2 capture, and so on. And our vision is marine future stream. And this picture drawn by the Japanese student shows our vision. And one is, which is composed with two concepts. One is to create a safe and a secure future for the society. And one is to realize decarbonization of the maritime economy. And our recent new building are shown here. So this is Japan's first LNG fueled ferry and Japan's first LNG dual LNG bunkering vessel, and the world's first liquefied CO2 carrier, which is dedicated to the CCUS project. And other symbolic project is this LPG dual LPG ammonia carrier, but this was actually two vessels, so they were built in Namura shipyard in Japan. So we are cooperating. We are trying to expand the collaboration with the other shipyards or our partners to expand the utilization of alternative fuels or more efficient vessel designs. So I used one keyword in the previous 3 slides, which is decarbonization. So maritime industry is faced to the goal of net zero by 2050, indicated by MEPC 80. And we have many options. Is it okay? Okay, so we have many options starting from here. okay, we are safe. Don't worry. So we have many options, sophisticated design and energy-saving device, starting from efficient hull form, propel refine, ESD, wind assistance, and rail lubrication, and so on. And we have also option as a carbon capture, onboard carbon capture. But I believe that we cannot avoid to use alternative fuel to achieve net zero by 2050. So which alternative fuel should be used? So we have many options as well. So FO, methane, methanol, LPG, hydrogen, ammonia. So, but each fuel has its pros and cons. So group 1 contains C carbon, and emits CO2 when burned. But it's relatively easy to handle compared to other fuels. And the second one, hydrogen, emits no CO2, of course, because it doesn't contain C in its in it. But we have to consider its extremely low temperature when storing on board the vessel. And the third one, ammonia, today's topic. It's toxic even in the ppm level, and of course the corrosive to the metals like coppers. But its characteristic is resembled to LPG, which has a long history as handled by gas carriers. So ammonia is one of the expected fuel to play an important role. So let me introduce about ammonia from the basic. So, though you might already know. So ammonia is a relatively low energy density. Has a low energy density. So this table shows the comparison between among the each fuel, and the bottom one is the tank volume ratio index compared to conventional FO. So if we set 1 for HFO, then the third column, ammonia requires 3 times volume as compared to FO to keep same ship's endurance. So need volume. And of course, ammonia is toxic, and it can be toxic even its ppm level, and it's also flame retardant. And then it can be a hurdle when we developing engines, and it's also corrosive to copper or other materials. So based on this, so considering these characteristics, we have to consider these items when applying ammonia fuel to the vessels. So first is the efficient arrangement. So different from the onshore facilities, ships has very limited space, so we have to utilize as much as possible this limited space. And second, we need a robust system. So of course, ships goes to the wide ocean apart from the land. So once the ship loses its power, the ship will drift. So many manufacturers of engine and ammonia gas supply systems are struggling to develop it as much as robust and as soon as possible. And the third one, though I listed in the third place, but this is the first priority, is a safe design. So we need to secure crew's health and safety. So against these hurdles, Mitsubishi Shipbuilding can offer design and construction of ammonia-fueled vessels and ammonia-carrying vessels. And second, engineering service to ammonia-fueled vessel design. And third, robust ammonia supply and safety system called Mammoth. I couldn't believe that our company named this latest system as Mammoth in the ancient age. But this is named after its powerful image. And some scientists said that mammoths became extinct due to the climate change, so high temperature rise. So I believe this mammoth can be solution to our problem, the net zero by 2050. So, as a sample of the first, second, and third item at the last of my presentation, let me introduce our activities. So this is the latest project on ammonia carrying vessel. So we have many experience of construction of LPG carriers, LNG carriers, or other type of gas carriers. So we began with gas carriers. Over a few years, we designed VLGC, very large ammonia gas carriers, and ammonia FSRU, ammonia bunkering vessels, and CO2, and ammonia carrier, and so on. And now we applying the knowledge and experience from this design stage to the other non-gas carrier, ammonia-fueled non-gas carriers, including container vessels, PCTCs, or tankers, bunkers, any type of whatever. And moreover, to expand the utilization of ammonia fuel more, we developed our own system, Mammoth, again, Mitsubishi Ammonia Supply and Safety System. This system composed of a fuel supply system and an ammonia gas abatement system. And in the bottom, so ammonia gas abatement system treats ammonia to the required level of concentration so that the vessel can emit ammonia, remain the ammonia gas safely to the air. And this system strong point is it's applicable to both of two-stroke and four-stroke engines, and any manufacturer's engine, MAN and Valterra, J engine or WinGD. So it's very flexible. And as shown in this picture, it's placed in the module, very compact way. And you can combine this module according to the ship's design, ship's arrangement. So it's very flexible when designing the vessel. And we consider the operability and maintenanceability on board the vessel as well. So this space-saving and easy maintenance module design and operability and maintenanceability will contribute to the expansion of ammonia fuel. And also, of course, we can you can design ammonia-powered vessels, combining our Mammoth system. And of course, we can do commissioning work and support of gas testing. So from the beginning to the delivery of the vessel, we can support the ammonia-fueled vessel design and construction. So in summary, we, Mitsubishi Shipbuilding, commits to sustainable decarbonization of the marine industry, collaborating with partners based on abundant experience and expertise of gas handling. So we also have a booth in the hall 4, just adjacent to the Kawasaki Heavy. So please visit us, and I'm looking forward to talk with you, discuss with you, and exchange our opinions. Yes. So that's the end of my presentation. Thank you for your attention.
Thank you, Mr. Saigo. Now I'd like to open the floor for the question. Please raise your hand if you have questions. Is there any questions from the floor? No? May I move to the next presentation? Okay. Thank you very much, Mr.
Thank you. Thank you so much.
Now let's move to the fourth presentation, which is the last one before the break. The next presenter is Mr. Katsuya Naito from Class NK. He will give you the transition support services of Class NK in his presentation. Please welcome Mr. Naito. Floor is yours.
Thank you, Hamanaka-san. Good afternoon, everyone. I'm Katsuya Naito from Class NK Green Transformation Center. I'm very glad to be here, and I sincerely would like to thank JSEA to invite Class NK to today's Japan seminar. On top of the remarkable effort and challenge to accelerate decarbonization by Japanese maritime stakeholders, I'll talk about how ClassNK can support the maritime industry during the transition pathway to zero emission. As we newly announced ClassNK Transition Support Services to comprehensively support the pathway to zero emission in April this year, today I would like to introduce a brief overview of the service with an example. At first, I would like to explain some background why ClassNK launched ClassNK Transition Support Services. In terms of regulations, IMO is expected to introduce new regulations to further accelerate GHG emission reduction, such as midterm measures. In addition, EU is also implementing their unique regulations, which are EU ETS and Fuel EU Maritime. These regulations will impose a financial burden on GHG emissions from ships and expected to become progressively more stringent. Strategic reduction of GHG emission is becoming a key element of the future maritime business. In this regulatory landscape, as a medium to long-term reduction measure, the introduction of zero-emission fuel ships is essential. However, since the infrastructure for zero-emission fuel supply is likely to be insufficient in the short time, to ensure a smooth transition, appropriate GHG reduction measures will be required to be taken. Under such circumstances, in addition to our existing support for GHG emission reduction, ClassNK has rebuilt the service and added new support to provide our client with comprehensive support for the realistic transition to zero emission. This slide outlines the ClassNK transition support services. Since it is thought that the current possible GHG reduction measure can be summarized into these three areas. Firstly, alternative fuels. Secondly, improvement of energy efficiency. And the thirdly is the use of onboard CCS. Our support mainly focuses on these areas, covering from introduction to operation. Moreover, we provide the tool to support GHG emissions management and latest information on IMO and EU regulations as a white paper and FAQ, etc. From this slide, I would like to introduce the overview of each support shortly. As for alternative fuels, in order to support the introduction, we published the Alternative Fuel Insight, which gives the trends of alternative fuel ships, alternative fuel supply forecasts, and cost simulation, etc. I will touch this insight later stage. In terms of safety aspects, ClassNK can support the introduction of all kinds of alternative fuel ships through providing guidelines for alternative fuel ships, which outlines the safety requirement for the design and construction of alternative fuel ships. In addition to guidelines for alternative fuel ships, NK can also offer technical support for the construction of new building ships, obtaining AIP, and retrofitting of existing ships utilizing our technical knowledge. We also recognize the importance of establishing an operating procedure and seafarer training requirement for alternative fuel ships because they directly concern to onboard safety management systems. To address these critical areas, we are actively preparing to issue guidelines detailing the operational procedure and seafarer training requirement on alternative fuel ships. We are also developing e-learning to support and enhance seafarer training. And furthermore, with regard to the use of the biofuels, since biofuels can be used without major modification of the existing engine itself, it is recognized that biofuels are one of the viable options in the transition period. So, in order to support the introduction and use of biofuels, we have issued a technical guide for using biofuels. We also believe that the needs of third-party certification will be increased for ensuring the reliability on decarbonization activities. For example, we can offer the certification service to certify biofuel production methods and GHG reduction effect, etc. As the certification area is one of our strong areas, we will continuously develop the certification menu for GHG reductions in line with customer needs and the regulatory situation. From here, let's move on energy efficiency improvement support. The energy efficiency improvement technology, such as wind assist propulsion system and air lubricating system and energy saving device, etc., have already been introduced on a lot of ships. On the other hand, the fuel efficiency of each energy saving technology is different, and the appropriate technology differs depending on hull form and ship type and size, etc. Therefore, it could be challenging to select the suitable technology on individual ship from a wide range of options. In the decision-making process, we provide the information and the current trends, such as which technology have been adopting on individual ship, how is the expected effect, how is the actual effect, and so on from our accumulated knowledge. And next, support for onboard CCS. We also recognize the increasing interest in capturing CO2 emissions from ships, and a lot of development projects of onboard CCS are progressively aiming for the practical use. However, international regulations regarding the equipment, installation, and operation of onboard CCS are still underdeveloped. In addition, there are also no established rules under IMO or EU for handling the captured CO2 and measuring the CO2. So it is challenging to consider applying onboard CCS. NK will provide and spread the helpful information on trends such as the introduction of onboard CCS, storage locations, and facilities for captured CO2, etc. We also provide technical support by issuing guidelines on the safety requirements for onboard CCS. In addition, it's expected that there is a growing demand for third-party certification of the actual amount of CO2 captured by onboard CCS to appeal to the relevant stakeholders. We are now in the process of establishing the certification scheme for the amount of captured CO2. Eventually, we will be able to support the entire process from the introduction of onboard CCS to the storage of CO2. So I have focused on the three main support in this presentation so far, but regardless of GHG emissions reduction measures, verification for GHG emissions from the ship is required, and management of GHG emissions from the ships is important for shipping business. So through our Class NK MRV portal, we verify GHG emissions under IMO DCS and EU MRV. We also verify GHG emissions for specific period or voyage and issue certificate to meet various verification needs. In addition to Class NK MRV portal, you can use Class NK Zeta, a tool for visualizing GHG emissions. This tool will help you check GHG emissions and CII rating, and it enables you to simulate potential change of GHG emissions and CII rating. It also includes EU ETS feature, and we plan to add the function of fuel EU maritime in near future. We actively disseminate the useful information on IMO and EU regulations. We published a white paper to analyze the IMO GHG reduction strategy adopted last year. We also summarize the information on the EU ETS and fuel EU maritime in FAQ format to assist in preparing for regulations. So finally, I would like to introduce Alternative Fuel Insight, which is one of the support services as example. This insight has been published last month, and our Alternative Fuel Insight consists of mainly 4 topics. First topic is understanding regulations. Second topic is understanding trend. Third topic is understanding alternative fuels. Fourth topic is understanding cost. This is an example of understanding the trend for alternative fuel ship. This slide shows the number of bulk carriers using alternative fuels in service and on order. As you can see in the bottom left side, we are providing information by ship size to help you understand the trend in ship size in your fleet. As for other ship types, please check out the full version of our insight. And this is an example of understanding a cost. This slide is an example of cost simulation for Ultramax bulk carrier comparing the total cost of adopting conventional fuel ships with ammonia fuel ships. And please also check other simulation result and the simulation condition in the full version of our insight, or please come to NK booth, ask and discuss the insight and the support services. We are waiting for you at booth number 10544. In order to be a reliable classification society for our customers, we will continue to work actively. That's all. Thank you very much for your attention.
Thank you, Mr. Naito, for your presentation. Now I'd like to open the floor for the questions. If you have a question, please raise your hand. Is there any questions? No? Oh, question here. Gentleman there.
Good afternoon. None has mentioned anything regarding to cost. I do understand, as per IMO, globally, everybody in shipping, either you are an owner, either you are a charterer, if you have to follow the IMO guidelines, the transition from 2025 to 2050. However, all of you, the Japanese shipbuilders, you are the aristocrats of the shipbuilding globally. But shipping, in terms of transportation mode, always it has been the cheapest mode of transport. There is none so far, with all these guidelines and transition curves representing, to mention costs. What do I mean about cost? We have to keep in mind that shipping has to be relative cheap in terms of transportation. I have done many business as a broker for Mitsubishi Grains, Shinwa, Energy United, and some other shipping companies, world traders. So I have an experience regarding to cost. Cost is very relevant. It's a relevant part of this equation That's it. You have to keep the cost to a minimum. Versus safety, versus implementation, versus the one, versus the others. You can.
Okay, thank you very much for your comment. So, yeah, actually, cost is yeah, important also.
It's the most important factor
Of the so, what is the most important?
You don't have to answer. I just mentioned that you have to keep in mind as a factor the cost. This is excellent. The presentation was absolutely excellent.
Yeah.
Yes. But we have to take in mind. We have a note.
Okay. Yeah. Thank you very much for your comment. I noted your comment, and we actually try to consider. We try to minimize the cost if we consider that some regulations. Thank you very much.
Thank you for your question and comments. Is there any other question? Gentleman there.
Thank you for the presentation.
Yeah.
So, considering UETS and Fuel EU, as a class, of course, you are providing verification services, which we are very well aware of. My question is, so UETS has its own life, own regime, kind of all the legislation and what it does. But Fuel EU is kind of also a parallel vertical, right? It is coming next year, but it has its own calculation, it has its own pooling mechanism, it has its own GHG reduction mechanism. So as a class, what do you see your role within that space? And a lot of technologies that are there in the market right now, some are already approved, some are maybe approved categories. So do you actively advise as a class, or what route do you take, you think is the best for the uncertainties as it is today? Thank you.
Thank you very much for your question. And I think the Fuel Maritime will be started next year, and I think existing ships will immediately change to use alternative fuels. Maybe at the initial stage, as you said, so most shipping company will use a pooling or pooling system. So we can we will plan to the Fuel Maritime function installed in our class NK Zeta. That is the tool for management of GHG emission and CII rating. So that means you will be able to handle your GHG intensity in our Fuel EU maritime function in class NK Zeta. I think that it is very helpful for you. So we will release the Fuel EU maritime function maybe at the beginning of next month. So once we will release, we will inform you. Thank you.
Thank you very much for your question. I'd like to take one more question if you have. Is there any question? No? Thank you very much, Mr. Naito.
Thank you very much.
Well, I'd like to have a break for maybe 10 minutes. The seminar resumes at 3 p.m. Please come back to your seat by 3 p.m. Thank you very much for your attention. Welcome back to our seminar. I hope you had a lovely coffee break. Then, I'd like to start the second part of the seminar. First of the second part, let's start with the fifth presentation. The presenter is Mr. Fumiaki Yukizane from Yanmar Power Technology. He will present you solutions for sustainable future by Yanmar Power Technology. Please welcome Mr. Yukizane. Floor is yours.
Nice to meet you. I'll explain product and technology for sustainable future. I introduce Yanmar's action, alternative fuels in four-stroke medium or high-speed marine engines. Today, I introduce biofuel and methanol, ammonia, and hydrogen. So we think alternative fuels depend on ship type, cost, and availability and time. So horizontal axis, cruising range, vertical axis, output. So ship types listed: tourist ships, tugboat, workboat, coastal vessels, fishing boat, grading coasting vessel, or ocean-going ships. So smaller cruising range and small output. It use batteries and hydrogen fuel cells. So cruising range is big. Far from cruising range is big. So output is big. This use methanol and ammonia. So we will think depend on ship type. So firstly, I will introduce biofuels. We will establish Kotaki Naval Research and Development Center in 2007 in Malaysia. So we will test it, small size engine and big auxiliary engine is tested. This is engine test is finished on customer. Customer name is Toyota Tsusho Corporation. The fuel is B50. Running time is around 2,000 hours. So carbon deposit, nozzle sheet and nozzle body is no problem. If you use biofuels, please refer Yama's service news. So if you use biofuels, please come to our booth. Next, overview of methanol fuels. We think combustion method of methanol is two methods. First is low pressure low pressure port fuel injection, LPPFI. This combustion process is methanol injected to intake port. They evaporate and form air fuel mixture and ignited by pilot diesel. Right side is high pressure direct ignition. This is like a diesel ignition. Methanol and diesel or directly injected into cylinder at the same time. This advantage, LPPFI, is a simple system relatively and possibility of retrofit and development periods shorter. On the other hand, HPDI is a high methanol ratio. This is a single-cylinder engine test for LPPFI. Now, single-cylinder research engine is test completed, so multi-cylinder engine test started in this year. High pressure direct ignition engine is now research engine. We will establish technology for the HPDI combustion for methanol. Next, ammonia fuel. This is also a single-cylinder engine will be tested. This is single-cylinder engine. Right side is a tank. Left side is a single-cylinder engine. So ammonia is harmful for person. So HC detector is like this installed. Effect of NH3 mixing ratio on GHG emission. If you NH3 mixing ratio increase, so but influenced by N2O emission. So I will decrease so N2O emission. We will after treatment like SCR, we will equip after treatment equipment. So we will develop N2O, NOx, and unbound NH3. Finally, hydrogen fuel. We will develop a hydrogen engine with a sponsored Green Innovation Fund. This engine developed with 3 companies. So this is development. Now single-cylinder engine test is completed. So we will multi-cylinder engine test will complete 2026, and high-speed spark ignition engine will be completed 2028. Next sponsored engine. This is a high-speed hydrogen engine. So bore size is 155 millimeter. This is sponsored Nippon Foundation. We will call Zero Emission Ship Project. Last one, maritime fuel cell system. This is, we will release this system last year. Output is 300 kilowatts, zero emission, no drag exist, low noise, and no vibration. Size is below, weight is 3 tons. This is test, outdoor test and incline test. Consider all piping and cable connection port are single side. And incline test, there is no problem of considered water in cathode size at inclination. Last, development schedule. Yanmar Power Technology is developing alternative fuel technology to all vessels in all type fuels. This is methanol, 6-cylinder, 220 meter cylinder engine by 2026. But 8-cylinder, 220 meter engine until 2029. On the other hand, hydrogen, we will end development 6-cylinder 220 meter until 2029. Also 155 millimeter. In summary, Yama's action in all directions towards alternative fuels in 4-stroke, medium and high-speed maritime engines. Yanmar Power Technologies development all directions to develop alternative fuels in all directions. Thank you for listening.
Thank you very much, Mr. Yukizane. Now I'd like to open the floor for the question. If you have a question, please raise your hand and wait for the microphone. And let us know your name and company in the beginning of the interview. Is there any question from floor? No? Okay, may I move to the next presentation? Is it okay? Okay. Thank you very much, Mr. Yukizane.
Very much.
So let us move to the next presentation. The presenters are Mr. Keitaro Nishiyama and Ms. Nanaka Beshi from both Daihatsu Diesel. They will present you power solution of Daihatsu. Please welcome Mr. Nishiyama and Ms. Beshi. Floor is yours.
It doesn't know work well. Just a minute, please. Thank you. Thank you for waiting. I'm started my presentation. Hello, yes. Welcome to my presentation and Japan seminar. Hello, my name is Nanaka Beshi from Technical Management Division of Daihatsu Diesel. I usually work on arranging each engine from a structural and electrical perspective in order to match the engine with the hull. It's good to see you all here. Welcome. Today we will proceed with the table of contents. First, who we are, and second, Daihatsu engines, and three, LNG DF technology, and four, new fuel to reduce GHG. At first, I talk about who we are. In 1907, we established the Hatsudoki Manufacturing Company Limited for the purpose of manufacturing the internal combustion engines. In 1966, Daihatsu Motor Company Limited's Osaka division, which manufactured marine and general purpose diesel engines, was separated to establish Daihatsu Diesel Manufacturing Company Limited. Now, the head office is located in the Medal Sky building and in Osaka, which is a landmark that can be seen from Osaka Station. During the Christmas season, a Christmas market is held on the premises and many people visit. If you came to Japan, please visit here. In addition, the factory where our engineering department is located in Moriyama, near Kyoto and Osaka. We are developing new fuel engines and producing small and medium-sized model. I also worked in Moriyama. We also have a factory in Himeji. We take advantage of our location, which is directly connected to the sea, to produce the dual fuel engines and the large models. Next, I introduce the global network. We have 38 branches all over the world, and with 11 locations in the European regions. Here in Greece, members of the European branch provide daily support. Thank you for always. Next, we will introduce our major products, auxiliary engines. About Daihatsu diesel generating engines for large ocean-going vessels, we have about 50% share for Japanese shipyards, and it has a market share of about 25% for shipyards all over the world. Thus, diesel generator engines are operating all over the world. Our company sells 6-cylinder and 8-cylinder generator engines from about 200 kilowatts to 4,700 kilowatts. Since it covers all range of output, it has a track record of delivery to various ship types: bulk carriers, chemical tankers, VLCCs, energy tankers, car carriers, ferries, workboats, etc. Since we have a large lineup, we will offer the most suitable model for your ship design. The engine type used in bulk and tankers in approximately 2018-2023. Total shipment of these best-selling engines are approximately 8,300 units. To continue meeting your needs, we are also working to ship these engines even more efficiently. And we also sell SCRs along with engines. In order to meet NOx regulations, we inject urea water to remove NOx from exhaust gas. The bypass perform the switching operations automatically according to the operating condition of the SCR system. No need to urea water in Tier 2 area. Of course, we have a lineup that can accommodate all output ranges of our engines. Our approximately 1,600 units have been shipped and installed on many ships. From now on, I will now turn it over to Mr. Nishiyama, who is responsible for the development of new fuel engines. Thank you very much. Next.
Hello, my name is Keitaro Nishiyama from Technical Management Division. I'm in charge of LNG-DF and will be involved in the development of methanol engine from this year. Daihatsu Diesel has manufactured numerous engines of various outputs, which have been chosen and operated by our loyal customers. Based on our reliable and high-performance diesel engines, we have developed natural gas-powered engines. We have completed shipping of 5 models. The LNG DF engine can reduce carbon dioxide by approximately 25% by using LNG fuel, but the GHG reduction effect is weakened by the occurrence of methane slip. We have worked to reduce methane slip and have reduced the methane slip of the engine alone by more than 40% compared to conventional engines at 50% engine load. Furthermore, with the aim of further reducing emissions, we are proceeding with the development of cylinder cut operation and oxidation catalysts. As the next stage of developing LNG-powered engines, we are making effort to achieve zero carbon dioxide emission from our engines. I would like to now introduce the current status of development of new generation fuel engines. Here is our development roadmap for future fuel compatibility. We aim to deliver our first commercial methanol-powered engine by the middle of 2026. For ammonia, we are targeting commercialization in 2028. If there is need for ammonia engine by the mid-2020s, we will address it through the READY program. Regarding hydrogen, we have been conducting basic research with subsidies from Ministry of Transport from 2021 to the end of last year. We have focused on basic research in collaboration with universities, and in last year, we have conducted more detailed hydrogen combustion tests using our single-cylinder test engine. Single-cylinder tests have already been conducted using methanol, ammonia, and hydrogen fuel, and the engine performance and GHG reduction effect of each fuel characteristic have been confirmed. Although this is still at the basic testing stage, we have confirmed that the GHG reduction effect is 12% for methanol, 82% for ammonia, and 96% for hydrogen compared to conventional fuels. At first, I will describe the development of methanol engines. Single-cylinder engine test has already finished, and recently, a demand of auxiliary engine for large container ships are increasing. So we are developing methanol dual fuel engine based on our Day 33 type at first. After development of Day 33, we will expand to smaller engine based on Day 23. I will introduce some of test results. There are 2 ways about fuel injection method, direct injection and port injection. We tried both, and here is a comparison chart. In the case of direct injection, methanol operation can be up to 100% load, and methanol ratio achieved 98% with only 2% pilot diesel. This is very good result because we use flexible micropilot fuel injection system. The direct injection method is suitable for larger bore engines. The combustion of direct injection was also very good without knocking. On the other hand, methanol operation range of port injection is only part load. Also, we found knocking with higher methanol ratio and higher load. The port injection method is suitable for smaller bore engines. The right side graph shows GHG reduction when 98% methanol direct injection test case. Even if very high methanol ratio, GHG reduction is only 12%. Further GHG reduction requires green methanol. Next one is ammonia. We have already completed single cylinder test in last year. The bore size is 285 mm. The highest ammonia ratio was 95% with 5% pilot diesel. In this case, GHG reduction was 82%. However, we found very high ammonia slip and nitrous oxide. I think ammonia 80% with 20% pilot is good balance from the viewpoint of exhaust emission. But of course, GHG will be increased due to increase of pilot. Anyway, we need more engine test and after treatment test. As I mentioned that the first ammonia commercial engine delivery will be in 2028. This is too late for the customers. We will apply ammonia ready concept. We deliver existing LNGDF engine as it is, then this part to be replaced on board later. Gas emission valve, after treatment, control system, and so on. And next is biofuel. Existing Daihatsu engines can use biofuel without any engine modification. FAME and HVO can be used with compliance of our guideline. Recently, shipping companies are using biofuels as onboard trial with Daihatsu engines. Most of them are B20 or 30 and maximum B100. Daihatsu asks customers to provide us a fuel analysis report. Then we will respond with some advice. Also, we will issue an objection letter as needed. In addition, I would like to introduce fuel cells. Toyota has introduced Mirai, a vehicle equipped with hydrogen fuel cell technology, into the market. We Daihatsu, as a member of Toyota Group, are also conducting research and development of divert fuel cell technology to the maritime use. Mirai means future in Japanese, and together with Mirai, we aim to create a future. In order to accelerate the development of new engines, we are planning additional investment to our Himeji factory to expand production capacity and also build new facility for future fuel engine manufacturing. The investment amount is expected to be approximately 60 million euros. Lastly, we are planning to change our company name next year. It will be Daihatsu Infineon. Infineon is a coined word of infinity and earth. Our group's corporate statement is technology for the earth. Through technology, we strive for harmony with the global environment and contribute to the realization of a sustainable society. Our new company name embodies our strong determination to provide infinite value to the global environment. That concludes our presentation. Thank you for your attention. We look forward to welcoming you at the Daihatsu Diesel booth. Thank you.
Thank you, Mr. Nishiyama and Ms. Bessie, for your presentation. Now I'd like to open floor for the question. If you have a question, please raise your hand. Is there any question from floor? No? Okay. Then I'd like to move to the next presentation. Thank you, Mr. Nishiyama and Ms. Bessie.
Thank you very much.
Let us move to the seventh presentation. The next presenter is Mr. Satoshi Makino from Mitsubishi Heavy Industries Marine Machinery and Equipment. He will give you the presentation about the application of turbocharger for new fuels and the solution of energy-saving technology. Please welcome Mr. Makino. Floor is yours.
Thank you, Hamanaka-san. First of all, please let me introduce myself. My name is Satoshi Makino from MHI MME, Mitsubishi Heavy Industries Marine Machinery and Equipment. I'm in turbocharger designing section for 14 years. I'm very glad to be here today. I'm going to talk about application of turbocharger for new fuels and solution of energy-saving technology. This is today's content. of our presentation, I'm going to explain the MET turbocharger introduction in section 1, application for DF engine in section 2, energy saving technology of turbocharger in section 3. After that, a conclusion in section 4. First, let me briefly introduce the history of MET turbocharger. The MET turbocharger was born in 1965 with the world's first fully anchored structure. Since then, we have improved the compressor pressure ratio, turbocharger efficiency, and capacity to meet the needs of market. In 2004, MET-MA was released to realize higher efficiency and larger capacity. In addition, the MET-MB, a high-pressure ratio turbocharger, was released to meet the demand for high scavenging pressure from the market due to Tier 2 regulations. In 2020, we released the MET-MB2 turbocharger, which is improved version of the MET-MB turbocharger. The MET-MB2 is the latest type of axial turbocharger, and I will explain it in next slide. This figure shows the main difference between MET-MB and MB2. The MET-MB2 turbocharger has developed to reduce the size of the turbocharger by increasing its capacity and efficiency. As shown in this figure, rotor components, for example, blade number and profile of compressor and turbine, have been changed. These points enabled MET-MB2 to achieve higher air volume flow and high efficiency, enabling it to be downsizing. Downsizing provides its weight reduction and space saving. On the other hand, the basic structure is the same as MET-MB, so MET-MB2 overhaul procedure is same as MET-MB. Next, let me explain about the application for DF engine. This table shows delivery records of MET turbocharger to WinGD XDF engine. We have delivered 226 turbochargers to these engines. MET was applied to the world's largest Otto cycle engine, as shown in this article. This table shows delivery record of MET turbochargers to MAN Energy Solution engine. Total 479 turbochargers applied to MAN DF engine. As you can see, MET has been applied to many engines using the latest fuels. This picture shows the first of ME-LGIM methanol engine with MET turbocharger. As shown in picture, MET-90MB, that is the world's largest turbocharger, and MET-60MB2 are installed. Several modes of tests were carried out at the shop test, and it was confirmed that the required performance was satisfied in all cases. Orders for turbocharger for methanol engine is steadily increasing. We also recently received an order for a turbocharger for a green methanol DF test engine. We have delivered MET-83MB for this test for this test engine. Several tests are scheduled in 2024, and we will cooperate with MAN ES and Hitachi Zosen for these tests. The MET turbocharger will also be installed in the ME-LGIA engine, which uses ammonia as its main fuel. This project is for Mitsui E&S in Japan engine builder. The development schedule is as shown in the table. We have already delivered MET66 MB2 for test engine in last year. This picture is a turbocharger with test ammonia engine. In cooperation with Mitsui E&S, we plan to conduct full-scale test for about 1 year. Also, we guess that the slipping ammonia flows into turbine side. Due to this, it has a potential of corrosion risk, so we plan to change some components. Specifically, the material of O-rings using rubber and labyrinths using copper are going to be changed as shown in this figure. We will also deliver the MET turbocharger to UEC LSJA engine, which is ammonia-fueled engine of Japan Engine Corporation. We will deliver MET53 MB2 in this year, which is a similar component parts delivered to Mitsui E&S. For hydrogen-fueled engine, we are discussing of turbocharger specifications with Japan Engine Corporation for UEC LSGH engine. We will deliver MET33 MB2 in 2025. We are studying of turbochargers in relation to the usage of hydrogen fuel. Next, let me explain about the energy-saving technology of turbocharger. From now, let me touch on the 3 solutions to improve fuel oil consumption. All of them can be done by retrofit work. The first solution is turbocharger cutout. This is an engine with multiple turbochargers, one of which is cut out. By using this solution, exhaust gas which is flown in operating turbocharger will increase. Thus, turbocharger during low load operation can be operated under the high efficiency region of it. Fuel oil consumption is expected to improve by approximately 2.5%. Some parts need to be replaced when turbo cutting is applied. In addition to this, the additional work is required on the engine side. This solution is applicable to all engines with multiple turbochargers. The second solution is variable turbine inlet system. It is called VTI. This system can change the nozzle throat area as 2 steps by using special nozzle and casing and butterfly valve. When the valve is open, the exhaust gas flows over the entire area of the nozzle as shown in blue, right side figure. On the other hand, when the valve is closed, the exhaust gas flows only to a part of the nozzle as shown in red. According to this function, the turbine capacity suitable for low load can be selected. These gas side parts need to be replaced when VTI system is applied. Fuel oil consumption is expected to improve by approximately 3.3%. This picture shows the exterior photo of MET VTI. VTI is applicable to this right side written MET turbocharger. Retrofit work can be basically completed by replacing gas inlet inner casing assemblies, as shown in these pictures. In addition to this, the additional work is required on the engine side also. This butterfly valve is operated by air, so air piping connection work and cable wiring work shall be needed. The third solution is integrated EGB system. As shown in this picture, It includes exhaust gas bypass system in turbocharger. This system is composed of butterfly valve and special casing. With the addition of integrated EGB, the exhaust gas can be bypassed during high load operation, and it enables engine tuning to suitable for low load operation. If EGB is installed additionally, EGB piping work in engine shall be needed basically. However, with this system, the equivalent mechanism can be achieved simply by replacing the parts of the turbocharger. This solution is applicable right-size turbocharger. Also, this EGB system needs some additional work by engine side also, same as VTI system. Fuel oil consumption is expected to improve by approximately 2.5%. Finally, here is the conclusion of our presentation. Our company, MHI MME, will continue to produce turbochargers that respond to environmental issues. Our turbochargers presentation is finished. MHI MME has a booth in Japan Pavilion at Hall 4. We look forward to seeing you at our booth. Thank you so much for your time.
Thank you, Mr. Makino, for your presentation. Now, I'd like to open the floor for the question. If you have a question, please raise your hand. Here you go.
My congratulations about your presentation. It was very interesting, specifically the section of savings with turbocharger. The three examples you have shown, we have already applied in some of our vessels. However, before 20 years ago, it was very well known the waste heat recovery, which some very great shipping companies, they have applied in many ships. How about that? What is your opinion about the future? Because the savings that time, it was about 6 to 7%, but it is considerable.
Thank you for your question. About waste heat recovery systems, our product MAS, that is consists of power turbine and steam turbine. We consider that is depend on the operation condition, but that is effect to reduce total fuel fuel consumption.
That means it is applicable sometimes. Correct? It is possible to utilize the waste heat recovery, yes or no?
We consider yes.
Thank you.
Thank you for your question. Is there any other question from the floor? Please raise your hand if you have. No, it's okay. Thank you, Makino-san.
Thank you very much.
So let's move to the next presentation. The next presenter is Mr. Keisuke Osawa from Chugok Paints. He will give you a presentation of anti-fouling technology by CMP, contributing to low emission as well as better EXI and CII. Just a moment. Please welcome Mr. Osawa. Floor is yours.
Mr. Hamanaka, thank you for kind introduction. Hello, everybody. I'm very glad to be here today. I'm Keisuke Osawa. So today I'd like to introduce our high-performance anti-panic technology. It contributes low emissions and EXI and CII. This is background. As you know very well, recently we are concerned about carbon price because EU ETS has already started. This graph illustrates the price of emission allowance in the EU past 4 years. For example, in 2020, carbon price is 20 euro. However, carbon price is increasing year by year. In 2023, carbon price achieved 100 euro, but has been volatile from 2023. That means it's hard to predict what worldwide like in the future. So we need to consider the energy efficiency of the ships accurately. This is our situation. First of all, we faced IMO strategy on reduction of GHG emissions. EEDI, EXI, CII is example of solution for compliance. What's more, EU ETS is big issue because shipping company must purchase GHG emissions from this year. In addition, fuel in maritime, it come into force from next year. It also contribute reducing the GHG emissions. So as you can see this slide, shipping company must have solution in order to follow this regulation. So what is the best solution for new rules? With Chugoku high-performance anti-fouling technology, it contributes your lasting business. This is our product. So we Chugoku have various high-performance anti-fouling. For example, left side, ultra-low friction self-polishing anti-fouling, Seaflow Neo series. For example, Seaflow Neo SLZ, Seaflow Neo M1+. We have a lot of achievement in shipping industry. On the other hand, right side, ultra-low friction fire-release silicon anti-fouling. This is CMP Bicone Plus. It has excellent anti-performance. Today, I'd like to focus on CMP Bicone Plus with advanced silicon coating. First of all, let me introduce our silicon technology. We have been developing silicon coating more than 40 years. For example, left side, BioClean Eco. BioClean Eco has been applied offshore facility and intake channel power plant since 1984. This bottom left side, yellow gate is MOSE project. This is also one of our major achievements. Based on this technology, we have been developing new anti-fouling for shipping industry. This is CMP Bicone Plus. CMP Bicone Plus has been applied worldwide trading ships, coastal ships, navy ships. It launched in 2014. As you can see this slide, so we have developed the best silicon coating over a long period of time. Next, I'd like to talk about CMP Bicone Plus key technology. CMP Bicone Plus has 3 key technology. One key technology is stable silicon polymer. So left side, so smoothness and low surface energy and elasticity. So it easily releases marine organisms. And second key technology is patented hydraulic polymer. This is our original technology. So it provides ultra-low friction and excellent anti-fouling performance. Third key technology is small amount biocide. It's only 5%. That means it very significantly decreased compared to self-polishing anti-fouling. Based on this technology, CMP Bicone Plus long-term excellent anti-fouling performance. This shows static test in Japan after 30 months. As you can see this picture, CMP Bicone Plus has excellent anti-fouling performance. So CMP Bicone Plus has been successfully based on this technology. So from now, let's check the Bicone Plus actual performance. First visible result is reefer ships after 27 months. Average speed, temperature, activity is like this. So Normally, ocean-going vessel activity is more than 60%. However, this vessel activity is only 33%, almost half. So it's very severe condition for anti-fouling. However, please look at this picture. This is before washing. So as you can see this picture, CMP Biochemical Plus excellent anti-fouling performance. No barnacle, no slime like this. Next vessel result, Ro-Ro passenger ships after 16 months. Average speed, temperature, activities like this. Sailing route is Indonesia coastal. As you know very well, Indonesia is very high barnacle fouling area because sea temperature is very high. So barnacle paradise. So that means also very severe ocean for anti-fouling. However, please look at this picture. This is no barnacle. So CMP Biochemical Plus has excellent anti-fouling performance, very interesting result. Final vessel result is container ships after 59 months. Trading route is worldwide. Average speed, temperature, activities like this. Please look at right bottom side picture. This is long stay point. She has anchored 2 months near Brazil. That means very severe condition for anti-fouling. But please look at this picture. Vertical area applied CMP Biochemical Plus. As you can see this picture, CMP Biochemical Plus free from fouling. So very interesting result and good achievement. So next, I'd like to talk about simulation of fuel saving performance. Simulation is container ships. If we estimate this condition means activity is 60%, speed is 50 knots, in service period 60 months, navigation distance per year 50,000, and fuel consumption 92%. Hull area like this, surface preparation is full blasting. One case is market average anti-fouling. Another case is CMP Biochemical Plus. This is fuel consumption. This is time. As you can see this graph, market average anti-fouling is increasing, fuel consumption is increasing year by year. On the other hand, CMP Biochemical Plus almost stable. That means CMP Biochemical Plus fuel consumption less than market average anti-fouling at all time. So next we'd like to talk about more detailed simulation by using our simulator. This is our simulator result. So this table shows fuel consumption, CO2 emission, and related cost over 60 months. Right side visible is fuel consumption, fuel cost, CO2 reduction. So as you can see this table, CMP Biochemical Plus fuel consumption less than market average anti-fouling. Expect benefit, it would be 50%. That means fuel cost, it would be $3.9 million saving. It's big save. In addition, CO2 reduction also CMP Biochemical Plus less than market average anti-fouling. Expect benefit 70,000. It's effective EU ETS cost. What's more, our simulator can predict CII rating. For example, left side anti-fouling, right side CII rating for 5 years. So as you can see this table, CMP Biochemical Plus good solution for CII rating. So there's one thing I'd like to share with you. Chugoku simulator is original system certificate by class NK. So left side our simulator have received certification class NK innovation endorsement. Also right side performance analysis have same certification. So we believe our certificate system could support you in growing a business. Now before I finished, so let me summarize benefit of CMP Biochemical Plus. So first point is patented hydraulic polymer and a small amount biocide. It provides free from fouling for long term and excellent static performance. Second point is ultra low friction and excellent anti-fouling performance. You can achieve fuel saving and reduction of CO2 emissions. That means you can save total costs. What's more, CMP Biochemical Plus minimizes the transfer of invasive aquatic species. This is our advanced silicone coating. So now before I finish, so I'd like to share with you. So we Chugoku mission is to contribute so humanity and society through our cooperative activity. So we believe we will be able to be your long-lasting partner in sustainable shipping industry. That's all for today. Thank you for attention.
Thank you, Mr. Osa, for your presentation. I'd like to open the floor for the question. If you have a question, please raise your hand. Is there any question from floor? No? Okay. May I move to the next presentation? Okay. Thank you, Mr. Osawa.
Thank you. Thank you very much.
So let us move to the next presentation. This is the last but not least one of this seminar. The presenter is Mr. Makoto Yamaguchi from Mitsui OSK Lines MOL. He'll give you the latest activity of MOL's wind propulsion technology in the presentation titled Wind Challenger for the Future Maritime. Please welcome Mr. Yamaguchi. Floor is yours.
Yes. Okay, thank you very much today, and I'm really happy to explain our update about the Wind Challenger project. So I think I'm the last one, so thank you very much for your patience. But maybe I feel the obligation to entertain you a little bit more, but I'm not so like man, so just enjoy our presentation. Thank you very much. Yeah, first slide is not so meaning, but I think we have kind of the slogan. So sailing continues from the ancient time. We see again the sailing in the future. Welcome to the World Wind Challenger. Okay. Yeah, first I'd like to explain the project history briefly. The project started in 2009. The project was started as a JIP. This is a joint work between the Tokyo University and the shipping industry. MOL was the leader of the shipping sector. After completion of the JIP in 2018, MOL took over this project together with partners of engineering vendors, shipyard, consultant, and academia. Shofumaru, it is the first ship which installed the Wind Challenger, was delivered from Oshima Shipyard in 2022 after due R&D for the industrialization. MOL established the MOL environmental vision in 2023. We assigned the Wind Challenger is our high expectation to contribute to the future zero emission vessels. Yeah, it's a little bit of problem. If I can read this one, it's much better to see this way. It's possible. Okay, okay. It's okay, this arrangement. Okay. Yeah, we announced the first Wind Challenger ship, Shofumaru, achieved 17.1% fuel saving of a day. Shofumaru completed 7 round voyages since her delivery in 2022. Peak record of fuel saving is more than 30%. One day average is 17.1%. And the voyage average is 5 to 8%, but sometimes it goes down to zero if the ship faced zero wind effect with any reason. Therefore, we understand the key is how to minimize the zero effect cases and maximize the time to obtain better marine wind condition. So it depends on the wind. So I think maybe you like to buy CMP BioClean Plus
But okay, in that case, maybe I need to continue this one. But maybe I think in the end of the presentation, you understand maybe why we are continuing this project. Yeah. This is the bit explanation about the wind propulsion system. You can see the list. We have simply 3 or 4 categories. Depends on the mechanism of the sail. The first one is hard sail, like a wind challenger or wind wings. I think BAT technology is also in the booth today. Rotor sail is the, maybe some companies doing it, but no sail anymore is the key to company to develop and to do the business now. And the suction wing is a very interesting mechanism, technology. E-sail is by the bound for blue, and the bent foil is the econo wind. And the kite it's quite very impressive. The innovation and project. I think now K-Line is doing well for the development. All are using the lift. Important is the lift created by means of the device. This is the key theory of the wind propulsion system. We touch upon the lifting mechanism in next some slides. Wind Challenger has a telescopic to move up from 23 meter to 54 meter height of full sail within 9 minutes. Rotating speed is within 1 degree per second. I think you can see the rotating as well. Yeah. Yeah, you can see the cloud. It's a little bit modified. Yeah. Okay. Wind Challenger, how it works. Yep. I think this is quite the important illustration. The device allows a wider wind range. No effective wind is only 50 degrees from the forward. To be effective to create the thrust direction power. The device can be automatically rotated into the position to maximize the thrust power. We call max lift, or minimize the wind, minimize the wind friction. We call this is a zero lift, according to the lift characteristics. I think this the value between this value between the zero lift and the max lift, that is the performance of the Wind Challenger. Okay, this is not for the technology, but maybe I like to a little bit touch upon the rotor sail and suction wing, how it works. Okay, rotor sail. Their flattener rotor rotates by the wind speed. That means the self-rotation by the speed of the wind to create a different wind pressure, making the lift of the thrust force forward. Okay, that is a mechanism. Rather than my explanation, it's better to see the illustration anyway. Suction wing. When suction on to the device, above wind flow will be attached to the sail to create the different wind pressure, making the lift of the thrust force. Like that. Suction off and on. Yeah, thank you very much for wonderful. Yeah. So a little bit explain about the different character. Wind Challenger is scalability is maximize the effective surface in consideration of the navigation visibility, telescopic and the rotation,
minimize the friction loss and the avoidance of the cargo operation by the condition such as lowest height and the zero lift direction. Weight. Minimize the weight by simple design and by using of composite material. But as a scale, it is the relatively bigger. Okay, for the rotor cell, efficient use of the wind power is a very technology by proven Magnus effect, which the flattener rotor rotate in various speed according to the wind speed. Tilting or shifting, minimize the highest or moving the position to avoid the disturbance of the other ship operation while she is in the port. Weight, minimize the weight by simple compact design and by using of the composite material. I don't think it's not so clear how much portion they are using the composite material, but maybe it's quite important to make it lighter. Suction wing, efficient function of the suction technology by switch on the rotator device for maximizing the thrust power by the wind speed. Tilting, minimize the height to avoid the disturbance of the ship operation while she is in the port. Weight, minimize the weight by compact design. I checked they don't use a lot of the composite material, so this is a wrong information, sorry. Yeah, all devices seems a good ability as long as the ship can receive the good wind direction and force. This is very key. So what is the next challenge for Wind Challenger? And this is a very important update for us. Okay, I think we can say we have the three arrows. The market important, operation importance, the production important. So in between the market operation, we see the regulation and also regulation challenge, and also the between the operation production, we need a safety challenge. And market production, of course, we need to challenge the competitive value we can provide to the customers. So a little bit detail. For the market, educational approach to the potential customer and appropriate price of device for its ability. For the operation, autonomous performance with a simple maintenance, safe operation for ship navigation and operation. Production, quality production with the ESG operation, reliable manufacturing schedule. Then we can go reliable device. So first, a little bit detailed explanation about education and understanding of wind propulsion system in the maritime industry. Today, I introduced that maximum effect of wind propulsion system is huge comparing with the other energy saving device, except the CMP BioClean Plus. The effect is depending on the marine wind power and the direction encountering during the ship navigation. Analysis of the weather prediction in the ships using navigation route shall be valuable. This is one of the new trend, how to use the Wind Challenger or wind propulsion system. We develop also the weather routing system dedicated for the ship with the Wind Challenger, which can help the captain may select more competitive routes in the operation. Okay, another challenge, appropriate evaluation and regulation to make sure the reliability of the device to provide safety value. MOL is only the company who operate as the ship owner and develop the wind propulsion system. This is very unique. This uniqueness is our advantage as we can improve the design based on our own data directly received from the ship with Wind Challenger. It goes to the appropriate balance between the design and the safety operation. From this nature, I believe we are one of influential position to cooperate the establishment of the regulation of the wind propulsion system. This is still in the process, but we really challenge. We are the position to influence very well to the newly established regulation. Yeah, that's the challenge. Thank you. And another one, appropriate price to provide the competitive value as much as ship owner can enjoy it. In order to achieve the appropriate price of Wind Challenger, we review our strong performance of the device, how to maximize the value for our potential customers. We also review all manufacturing process in order to create the reasonable cost mechanism and improve the operation service for all our customers can enjoy safe and competitive and environmental friendly operation. MOL now established the project team. Today, I'm one of the project member. Also, Onuki-san is the new project leader. To challenge all to improve our fleet value and to aim at the customer satisfaction. We also continue the engineering challenge for the future ship as below. The concept is to use the wind energy as much as possible, as it is a genuine free nature and the pure environmental energy resource. Okay, left-hand side is the more Wind Challenger on board, but because of the safety, visibility of the from the bridge, so we newly designed our bridge is the forward. I think it used to be there this type of the ship, but nowadays basically the design of the bridge is the aft. So that's why this is a very new. But important is we can install many Wind Challenger to get good power from the wind to reduce the CO2 emission. Right-hand side is the Window Hunter. It's a little bit deformed. It is a little bit too much the Wind Challenger sail. But I think this is the image. That ship can produce produce the hydrogen by the wind power. Create the electricity and to create the hydrogen. So we can storage the hydrogen on board and to bring some some place shore and to discharge that hydrogen to the shore. Okay, it's a very pure natural energy change to the hydrogen for the next energy. Yeah, thank you very much. Please contact MOL for any question about the Wind Challenger. Thank you very much.
Thank you, Mr. Yamaguchi, for your presentation. Now I'd like to open the floor for the question. If you have a question, please raise your hand. Is there any question from floor? No?
Yeah, he said any question, please.
Please. No? Okay. So I'd like to finalize this presentation. Thank you, Yamashita. Now we finished all the presentation. Thank you very much for your active session with questions and comments. At the end of the seminar, we like to invite Mr. Shigeki Kinoshita, Chairman of the Japan Ship Machinery and Equipment Association, to give the closing remarks of the seminar. Please welcome Mr. Kinoshita. The floor is yours.
Hamanaka-san, arigatou gozaimasu. Unfortunately, this seminar is closing now. Thank you very much for all presenters and all audience. My name is Kinoshita, Chairman of Jasmiya and Chairman of Daihatsu Diesel. I would like to express our special thanks to Mr. Stelios Cordios for tremendously helping us organizing this seminar. Thank you very much for your a lot of great support. As we mentioned in presentation today, Japan marine industry are working together with the government and private sector to decarbonize the country. Since today's introduction was brief, with that you will visit to Japan Pavilion during Posidonia exhibition for a more in-depth exchange of information. We all hope that today's seminar will be meaningful as to further enhance the relation of trust between Greece and Japan and to start to collaborate more in new business field more than before. Thank you very much for participation today. Thank you very much.
Thank you, Mr. Kinoshita, for your closing remark. So, how was the seminar? I hope you all enjoyed it very well. You know that the achievement of decarbonization is a real challenge, and Japan can help you with a new technology to overcome it. Japan is exhibiting at the Japan Pavilion in Hall 4. You can find very easily from the entrance. The pavilion consists of the Japan Ship Exporters Association's booth in 4.202 and the Japan Ship Machinery and Equipment Association booth in 4.11 and Class NK's booth in 4.15. Please stop at our pavilion and feel free to ask about the latest advanced technology at each booth. In addition, there will be a series of presentations from Japanese industry at the Japan Pavilion from 1:15 p.m. tomorrow on Wednesday, 5th of June. Please visit the pavilion to see the presentation. Program for the presentation is available online, and also you can find this brochure outside of this room. You can take it. You can actively communicate with the presenters in the pavilion as well. All right. It is time for closing. Thank you very much for all your participation. Once again, please give a big hand for all speakers. I hope you enjoy your remaining stay in Athens and Posidonia. Thank you. See you next time.